All right, so we're live now. Welcome back, everybody. It's been kind of a long hiatus for the Open Ag Learning Series. I think mostly because everybody's probably been busy with field work as summer and fall have wrapped up. But we're back. Same format as usual, but we'll probably be doing it a little less often, about once a month or so, maybe once every 2 weeks as people are available. But just a recap of what our intention is here is to kind of have a space where people working on different open source technology projects in agriculture can get together and chat and just record these conversations so that folks who are kind of coming into this this area can have some resources to check out as they explore. So I'm Dan Kane. I am a research technician with Michigan State University, although I work remotely now from Burlington, Vermont. And I'm excited for this week's presentation. So let's do a quick round of introductions, and then we'll let RJ hop right in. So Dorn, go ahead.
Sure, Dorn Cox, farmer in Lee, New Hampshire, and physiocrat and board president of FarmHack. And excited to have RJ, a longtime FarmHack collaborator, and Mike Stenta with FarmOS. And I just a quick comment that I just heard from Lynn Carpenter-Boggs of WSU that she'll be able to join us next week to talk about the OFOOT software platform.
Awesome, great.
Yeah.
All right, and Mike?
Hi, yeah, I'm Mike Stenta, lead developer of the FarmOS open source farm management project. I've been working with RJ and Dorn and Dan for a while now, and RJ and I have just been working on some OpenPipeKit integrations with FarmOS, so maybe we'll show some of that too, but yeah, excited for this call.
Great. And with that, RJ, go ahead and take it away.
Hi, everybody watching. I'm RJ Steinert. I've been a computer programmer for the past 10 years since I graduated from the University of Vermont. And like all these fellows have mentioned, I've done a lot of FarmHack collaboration with them. I first got involved living in Portland, Oregon. I first got involved with environmental monitoring of compost piles. I had a friend who was trying to increase transparency of composting activities in neighborhoods to try to change some laws around some restrictive uses of what you could do with compost. And they had this problem where the technology was out there, they could send the data places, but they couldn't necessarily control where the data went, and they couldn't control who could see it, and things like that. And so I developed some software. That was about 6 years ago. That was a piece of software called SensorHub. Since then, I've also worked on the Apitronics Hive project, which is a little computer that sits at your house and collects data from bees. They're remote sensor nodes that sit in fields. And more recently, I've been working on a project called OpenPipeKit, which I'm here to talk about today. I'll sort of leave it at that for now. Unless it's presentation time. Is it presentation time?
Sure. Yeah.
Okay, great. All right, so how much time do we want to give for the presentation? And I understand questions we want to do as well.
Yeah, kind of whatever it takes, really. But 20 to 30 minutes, I would guess, for the presentation. Normally we take probably about 45 minutes to an hour for the whole call, but
okay,
always varies. So
cool. All right, so some quick background on OpenPipeKit. What is the problem that this project's trying to solve? So we're seeing a lot more this whole Internet of Things phenomenon happening. It's the idea that we're able to connect devices, whether it's your washing machine or your car or your light switches, to the Internet. And when you connect them all together, they somehow get smarter, and they somehow empower you to do things and that you couldn't otherwise do. And there's new use cases, lots of potential. They're saying like trillion-dollar industry or something like that. And but nobody really knows what the Internet of Things is yet. What we do know so far is that we are getting a lot of devices out there that have the ability to say, hey, I have data. And so as soon as you have a device, like let's say your washing machine that says, hey, I have data, the next question is like, okay, what do we do with that? And so that question is not really answered for washing machines. But there is the technical problem of, like, even before you can do something with the data, you have to get it somewhere. If the washing machine is just sitting there with data, and you need to know the status of your laundry when you're upstairs, away from your washing machine, that data needs to get to you somehow. And so that's the internet, is what the internet is for. This internet of things, these things that will connect to the internet, and so that you can be away from that thing, but still see it on the internet. And so the analogy that we use for how the data gets from a thing to the internet, the analogy we use is a pipe. And so that's where the name comes from, OpenPipeKit. And so what OpenPipeKit is some software that allows you to take a small computer like the Raspberry Pi computer and say, hey, Raspberry Pi, listen for data from that thing over there and pipe it to somewhere on the internet that I tell you to. Why is that important? It's important because typically the washing machine would only pipe data. It might know how to pipe data, but it would only pipe data to one place. And that one place would be, that one proprietary database in that one location. And then if you had your car also talking to the internet, then it would be able to send that data to the internet to its own proprietary database that is then in that website. And then if you want to see what the temperature is in your chicken coop, there's a device that you can put in your chicken coop, and it will send data to another website on the internet. So if you have a lot of things that are talking to the internet and you want to be able to control them all, your first problem is you now have, for everything, a new place that you have to look at for your data. For everything, you have this proprietary database that you can't control, and you just have lots of websites you have to visit. That's just kind of a pain. There's also concerns about privacy and what you can do with the data. When you set up your device in your chicken coop to send data to the internet, to this proprietary database, who really owns that data? Do you? What can they do with that data? Can they use that, sell that data to people to potentially target you for advertising or for regulation or things like that? So there's a lot of questions about the freedom that it is. So it's both in the Internet of Things we have a challenge of freedom, and we have of choice of where your data goes, and we have a challenge of just convenience, of being able to say, like, why can't all my data go to the same place? So OpenPipeKit gives you the ability to say, hey, washing machine, hey, chicken coop, hey, all you things. This is going to pull data from all you things, and it's going to push it not just to one particular proprietary database. It could if I choose so, but it's going to go to the database that I choose. And luckily, we have Mike from FarmOS here, which is one of those places that we can send data to. And that's an example of a place that we can send data that gives us control of our data. And so with that introduction, if I haven't bored you too much, I can move on to a demo real quick of one, where to find resources about how to get one of these built, and also give a demonstration, if I have enough time, of showing you guys actually me telling this device to pull data from something and push it somewhere. So without further ado, actually, you know what, is there any quick questions from the audience before I continue on with anything I missed that you guys think is important?
Sounds good. No.
Yeah, that sounds good to me. I'm sure you'll get to this too, but if you could show some of the different kinds of sensors that are relevant to agriculturalists and
Cool.
how they might be integrated, that would be awesome.
Cool. Sweet. All right. Well, to answer that question brings me to my next step. Is there is a website. I'm already on it, but you go to openpipekit.org, and it actually forwards you to our actual site where it's being hosted for free by GitHub. Thank you. Where we have guides and examples and our chat if you want to chat with us, and a forum where we discuss things, list of events, wiki for our documentation, and a configurator, which we'll get to in a second. So openpipekit.org has tons of information on how to build your own pipes, and also connect with the people who are working on OpenPipeKit and using OpenPipeKit. So your first step, if you want to build your own pipe, is the guide. So step one is plan. And what I'm doing right now is I'm going through these steps, and I'm trying to create helpful videos for each of the steps. And so what you'll find in each of these steps, or right now just a couple of these steps really, is these videos where I talk through some of the aspects of these steps that you'll want to consider. So your first step is just planning, like what is it you want to collect. You might have something in mind already, and the first thing I suggest is to check out the list of sensors that we currently support. And so in this video here, I pretty much demonstrate this by clicking on Configurator. I see a list of the sensors that we currently support, and this is just so OpenPipeKit's been around for just a couple of months, and so this is the number of sensors that we've had time to develop for in just the past couple of months.
Could you do a quick screen share of that list?
Oh shoot, I thought I was screen sharing. Sorry guys. All right, let's try that again. So, going to openpipekit.org. As you can see, it forwards us to our site that's hosted for free by GitHub. Thank you. And here's those links that I was referring to, the guide, the examples, some videos of examples of pipes. This is our chat room, which you can just use in your browser. It does require a GitHub account, which isn't too hard to sign up with. We have a forum, which is actually an email listserv hosted by Google. And they're being a little slow. And we have a list of events. Every Thursday night we do a hangout, and every month I post the next 4 links for our hangouts that we do. And we have a wiki where we store a lot of our documentation. And lastly, the configurator, where this is the program online that we use to be able to configure our pipes, to say like, hey Raspberry Pi computer, pull data from this sensor and push it to this database. So as you can see here, we have only a certain set of sensors and databases that we support. But this is an open source project. And so if you are a developer, we have in the wiki, we have documentation for developers on how to develop your own pipe CLI, it's called, and add it to this list. And so, all right, so this is just a general view of what we have. Here's that plan document that I was talking about, and the videos that we have at the top of these steps. And so you just go through. If you're interested in creating your own pipe, I would recommend going through and reading the documentation on each of these 5 steps and watching the associated videos. And again, I'm working on step 3, 4, and 5. I've got 1 and 2 done, but we'll have videos for 3, 4, 5 soon. And so yeah, okay, so let's do a quick demonstration. So let's see. I've got. I'm going to switch back to video here. So we'll just go through the steps. So step 1 is plan, and really we suggest you check out the configurator and you see what things we currently integrate with, and you think about like how they can solve your problems. So for example, here we have, if I want to know the temperature and humidity in my greenhouse or in my my chicken coop or something like that, there's this handy device called the TI sensor tag, which is a potential option. But there's which has a humidity sensor and temperature sensor and various other things. There's also other options. Here's a USB temperature sensor, and a lot of these, another humidity temperature sensor. Some of these are more for more advanced users, so they require like some soldering and things like that. But then some of them are also plug and play. So like the USB devices that we have here, the Bluetooth device that we have here, these are very easy for people to get started with. Whereas something like the one-wire temperature sensor takes a bit of soldering, but it also has a payoff. It comes because you have to do some of the work yourself. You can have a lot more sensors for a lot less cost. So that's one thing to consider. But today I'm going to demonstrate real quickly just our basic hello world. You actually don't even need a separate sensor. The Raspberry Pi actually has a temperature sensor inside of it that we're going to read data from. But before that, so that's our kind of our plan, and then our step 2 is to order the parts that we need. And I go through a little guide here of like, here's the list of parts that you're going to want to get, and in the guide I talk about like where to get them from, how to get it for cheap. I also have links here to like all the different parts and from the suppliers that I think are offering the best prices right now, and also the most reliable devices. So it's about, if we look at like 35, 12, 4, 8, 15, it's about $70 to build a kit. And then you have to get a sensor. We don't have to get a sensor today because we're just going to use the sensor that is inside this thing called the Raspberry Pi. If you haven't heard of the Raspberry Pi, it probably sounds really silly, but it's actually a really great computer that comes, that's for $35. And so that's kind of our brain. And the thing that's going to sit there, a robot that sits there diligently pulling data from the things around you and pushing it to where you tell it to. So actually, let me switch over to video and I'll show you guys what I have here. I think that's the trick. Yep. So again, going to this guy. So here's the Raspberry Pi. I open up this the lid, and we can see inside it's a crazy looking circuit board, but it's a computer, and it's like credit card size. And the other things that we have is this Wi-Fi dongle. You don't have to get this. You can actually plug the Raspberry Pi directly into your router through Ethernet. But if you can't necessarily place your pipe right next to your router, then the Wi-Fi dongle is a good option. And lastly, there's this USB thumb drive. The USB thumb drive is for downloading our instructions for the Raspberry Pi and delivering it to the Raspberry Pi so that it knows what to do. And also to note on that list is this micro SD card. This is the memory for the Raspberry Pi, like the hard drive. It doesn't have to be particularly big. I actually have a 16 gigabyte one here, which is too large. But the one that I suggest in the documentation is I think 8 gigabytes. And that's plenty of space, and only $4.
Hey, RJ?
Yeah.
Is there a reason you choose to use a Raspberry Pi instead of something like Arduino? Just curious.
Sure, great question. So that came from the question of, okay, so we want to find a way to empower non-technical users to be able to say like, hey, I want to pull data from that thing and push it over there. And what that requires is it requires a lot of programmers making code that pulls data from things, and then on the other side, pushing data to databases. And so one of the reasons we went with the Raspberry Pi was that it allows you to write those what we call the pull driver, which is what pulls data from something, and the push driver, which pushes data to databases in any language that you want. So whether it's PHP or C or Ruby or JavaScript or Python or Haskell, we joke about sometimes, you can write your drivers in any of those languages. The Arduino was limiting in that way, and there was also complication as far as like memory limits. If you combine a pull and a push driver that was just written in for Arduino, are they going to hit memory limits and things like that? It's just a harder problem to solve. And for a device that is going to be sitting usually at a actually here I have a diagram here that I'll show you. So your typical farm kind of setup looks like this. I don't know if you guys can see. This is a demonstration I was making for someone just the other day. This is your house on your farm, and here's your chicken coop, and here's your greenhouse, and here's maybe a grain silo. And you've got your pipe, you've got your internet connection at your house, and so you place your pipe here at your house, and what it's doing is you have a device in your chicken coop and you have a device in your greenhouse and in your grain silo, and they are sort of chirping data out, and this pipe is catching it and piping it to something like FarmOS. And so Arduino is often like useful. Like one of the nice things about Arduino is it's lower power than the Raspberry Pi. But if it's going to be plugged in at your house, it's not like we really need to. Not like we have any lack of power in houses. So that wasn't necessarily a design constraint that we were concerned about. So does that answer your question?
Yeah, that definitely. Yeah, just that it's a simpler thing to work with in multiple languages. Whereas Arduino, I think you're limited to just C.
Yep,
basically.
Exactly.
And
Yeah.
C is hard enough.
So,
And also, you can also think about the Arduinos as those, or the Arduinos themselves could be used as the things that are transmitting the data in other places, but the pipe is a Raspberry Pi.
Yeah, so you typically have your sensor nodes, and then you have what we call in the industry a gateway. And inside the gateway, there are pipes that pipe the data from the sensor nodes to the internet. And so OpenPipeKit is really all about building gateways to be able to pipe data from sensor nodes in. The Arduino, as Mike mentioned, is a good option for building sensor nodes, but not necessarily a great gateway.
Great. That's a perfect answer. Thanks.
Yep. All right, so where were we at? Getting to the fun part here. Finishing our gateway with a pipe on it. We are at step 3. Build. We don't have much for this so far, but it pretty much involves, there's some software that you need to put on the SD card here. We have instructions here for that. Really want to make a video for this one, because I think this is one of the harder parts. So if anybody is attempting to do this, feel free. Thursday nights, OpenPipeKit calls, 7 p.m. or 8 p.m. Also potentially you can catch me on the farm hack call at 7 p.m. To help troubleshoot any issues that you have, or if you just want me to be there while you're trying to do this, and I would love to help. So pretty much, but for the most part, that's the hard part, is just like copying some software onto this SD card and then snapping these pieces together. And it's all pretty much plug and play. Moving on to step 4, configure. So what we do now is this is where the USB thumb drive comes in handy. We use this thing we call the configurator. I'm going to go to screen share now. We use the screen share. We use the configurator to create a pipe. And a pipe contains a pipe knows data from and where to push it to. And so using our configurator, if anybody actually has a better name than configurator, feel free to shoot me a suggestion. Configurator for now. So I know I have my Raspberry Pi. I'm just going to use the temperature sensor inside of it just for this demonstration. And I'm going to have it pushed to Google Sheets by CloudStitch. So what does that mean? CloudStitch is a website where you can set up a Google Sheet that data can be pushed to. So I'm going to select this option. And it asks me for the configuration for the database. So it's asking me for a URL. The URL endpoint shown in your Magic Forms project on CloudStitch. Make sure to turn on auto add columns. We're going to do that right now. This is cloudstitch.com. Go to my projects. I'm going to add a project. Select Magic Form. Try it out now. And for those who are may be getting lost right now, I'm going kind of fast. I have a whole video of doing this on the example section of openpipekit.org. So the thing that it told us is to make sure we have on auto add columns. I'm going to turn that on. And then it's asking for the URL endpoint shown in your Magic Forms project. That is here. I'm going to copy this and paste it here. And go to next. How often? We're going to save data every 10 seconds. How will our gateway, connect to the internet? I'm going to do Wi-Fi here. So I put in the name of the Wi-Fi network here, which is Pirate Ship. Don't have a password. It's an open network here, but if I did, I'd fill it out here. Click next. Now it says download. So the pipe is ready. We have the pipe program, and we're going to transfer it over to the Raspberry Pi using this USB drive. So I'm going to plug my USB drive in and just look. Find my USB drive. Let's see it show up. Yep. All right, and it's empty. That's good. And I'm just going to save as onto my USB drive. We're saving this file called autorun1.sh. That looks good. Great, it's downloaded. I can see that it's on my USB drive. I'm going to eject it from my computer here and plug it into the Raspberry Pi. I'll switch back to camera real quick because there's some visual feedback that our pipe's going to give us. It's important. Great. All right, so as you can see, I have the USB thumb drive inside of this thing. And I'm going to plug in the power cable here, unravel it, and plug it in. All right, so now the thing that we're going to look for is this green light here. So at first, what it's doing is blinking erratically. That just means it's waking up. And then soon we will see the single flash, which means it's installing. It found our pipe, and it's downloading some of the dependencies. So for the programmers out there, this is if they selected your pipe CLI, it's now downloading that code. And in just a minute, oh, here's a good thing to point out. On this Wi-Fi dongle, if you see the flashy like it's doing right now, that means it connected to the router. If you see a solid light, it's a no-go. You may have done a typo. In which case, this this would actually finish, but your sensor code would not be there. In new builds, we're going to be getting this red light to actually be an indicator. So if there's like a problem, that this thing will probably flash. Now, on the green light, we see a heartbeat flash. That means our pipe is alive. So if we go back to our Google Sheet, oh, it's got a screen share. And open our Google Sheet. We see data.
Great.
So what we'll see here is the temperature value of the Raspberry Pi, and its first name and last name. This is very important. Okay. These are columns added by the Cloud Stitch by default. We can actually delete these if we don't want to see them. I'm just going to remove these columns.
So RJ, those two other columns, the value and timestamp, are those added because you turned on allow add columns?
Exactly.
Okay.
Yeah. So if you don't turn on the allow add columns, you'll just see the first name and last name because those are the default columns for them for some reason, and you won't see any additional columns or data because it can't add the value and timestamp column. So we can see this is coming in every 10 seconds. You'll see that like it doesn't come in exactly like 10 seconds, like there's 15 seconds between these two. That's because it's 10 seconds every time it tries, and so tries to do the reading and send the data. And so there's a little bit of processing time there. It's like when it goes like, okay, 10 seconds have passed, time to get the data, and now I send it, and now I wait 10 seconds. So you sort of see this fluctuation. And 10 seconds is even really kind of like a really fast rate. For most applications, I think we'll see something more like 5, 10, 20, 30 minutes for most things that people really care about. So anyways, but as you can see, this is just a really quick setup. This is our standard hello world for OpenPipeKit. This is so if you get all the parts and you just want to give this a try. If you have a Raspberry Pi right now, you can just try this right now. Because the Raspberry Pi has a temperature sensor on it. We can actually see that the temperature of the Raspberry Pi is going up because it's on. If I take the hood off of the Raspberry Pi, it'll go down slowly, or it could still be going up actually. But all right, so let's see. We covered, just to review, we covered why OpenPipeKit is necessary. Is because there's lots of things out there that we don't have control of where that data goes. And we would also like the convenience of having all that data go to one place. And we also covered what is the support that you currently have for building pipes. Again, the OpenPipeKit website has your guide, has examples, it has chat. You can catch us at any time. I'm always on this thing, and a couple other people. There's our forum, and there's events, which you're always welcome to join. Our wiki, if you really want to dive in, and of course the configurator, which is going to give you, allow you to build a pipe. And so that is about it that I have for presentation today. There was that one question of what sensors are there out there relevant for agriculture. Right now we are in the process of saying like, hey, we have this system. It works, seems to be working pretty well. Let's start integrating with more sensors that are agriculture oriented. And so we're evaluating a number of sensors that have been traditionally used in agriculture, things from soil moisture to NPK values to well, actually, you would be surprised at how many things just doing temperature and humidity cover for use cases. Some of the things that we're really excited about is these small wireless devices that can run on a coin cell battery for a year, without you having to like go and fidget with it or anything like that. So you can just throw them around, and they should just work. Unfortunately, just for example, this one's using Bluetooth, so your pipe has to be pretty close to where the Bluetooth device is. Here in Cambridge, we were experimenting. It goes about a block and a half away from us, but if you have buildings in the way, it's not going to be able to capture that. So we're going to. I think my next step for building sensor drivers is really looking at more of these long-range wireless protocols and sensor nodes. So there's, for example, on the APtronics project, they have the B, which is using the XB protocol, which is very long range. There are the Libelium WASP motes, which also use XB, which is very long range. So that's the kind of case where your greenhouse could be half a mile away and be communicating wirelessly to your pipe at your farmhouse. So there's also this developing new wireless technologies that go even farther, that go miles, and those are often one example of that is called LoRaWAN, and so those things are just starting to come to market. We're very excited to see that starting happening, and I'm excited about OpenPipeKit being a solution for folks to be able to use as a gateway to control where their data goes. So that's about all for me. Any questions?
Yeah, we'd also talked about a lot of use cases around not just moisture meters, but simple water level switches and so forth.
Absolutely.
So that can be binary as much as just a float valve and so forth. But I know that there's conductivity that's fairly low cost and really easy to. That would be an easy one to add.
Yep.
I was hoping, since we've got Mike on too, and we've already had FarmOS and some of the other projects that are integrating in with FarmOS, if you might talk a little bit about the work that's been ongoing with that so far in progress and next steps with that aspect of the project.
Sure. So we had Mike and I had a good weekend the other weekend, hacking out a really great start on that integration, and so FarmOS now has the ability to accept data from a pipe, and so we spent all day actually just figuring out how best to architect that in a secure and user-friendly way, and I think we're pretty excited about what we came up with, and we're testing that right now. We still have some more work to do on the user interface part, so that people can see in FarmOS graphs of data. And so that's our next steps on those pieces. I think in the next month or two we should see those features landing. And Mike, do you have anything you'd like to add there?
No, I think you summed it up nicely. Yeah, so the graphing and the kind of alerts, I think, are the next things on the list. I can share my screen real quick and just show oh wait, never mind, I can't. I forgot screen share doesn't work in Chrome for me.
Oh no.
I was just going to show kind of some of the data that we were piping into Dorn's.
Right. And
site.
I guess that was live yesterday, but I guess there were a couple changes. But otherwise, I could show it on my screen. But it was definitely working. We were getting live updates fed directly into the sensor field in FarmOS. It was pretty exciting.
Awesome.
And I guess sort of the other aspect of that is that we've been the applications, I think, for FarmOS also parallel some of the work that you've been doing with some of the UNH climate study projects, and using OpenPipeKit to evaluate low-cost sensors along with some of the more expensive commercially available sensors, and starting to validate and compare error rates and so forth.
Yep.
I know that the Climate Hub was particularly interested in, the Northeast Climate Hub was particularly interested in in that aspect as well. So maybe you might spend a little time on that.
Yep. Yep. So that's worth mentioning there. A group that's already doing those comparisons between the more traditional, more expensive sensors and contrasting them against the newer, cheaper sensors. The group called Public Laboratory is working on air quality monitors, and so you'll actually see on the OpenPipeKit configurator a number of both very expensive air quality monitors and some very affordable air quality monitors, and they're using OpenPipeKit to collect that data from the two different devices at the same time in the same place, and they're able to say like, wow, they collected the exact same data, so the cheaper one is worth it, or whoa, the cheaper one was way off. So they're figuring that out. In particular, like that's one of the challenges around like trying to understand, when they see that the data on the cheaper sensor is not as either as accurate as they want or just completely wrong, is how do we fix it, and is there a way around that? And so that's actually, they're working on airflow issues on one of the cheaper ones and building cases and things like that. Something that they might be able to have a breakthrough on by just using things like 3D printers and duct tape. So
cool. And yeah, I'd add to that part for a little context for viewers or folks who are not familiar with traditional ones that are used in science that are from proprietary sources. They can cost several $100s just for a setup that will give you about maybe 4 soil moisture readings or something like that. That can cost as much as $600. And like this, that can be wirelessly integrated and give you real-time data and is way more cost-effective. Is also, I would say, going to be exciting for people who do agricultural research.
I think it's worth noting on the cost that a lot of these companies charge. I think it's a lot of times it is justified, particularly. It's justified using because of given the technology and the infrastructure and specialties that they have. So if you are depending on a database, an online database solution from a company that has traditionally just done small microcontrollers and sensor nodes in the field, that's not their expertise, and it's going to cost more coming from them. And so one of the goals of OpenPipeKit is to say like, hey, hardware manufacturers, you guys don't have to do that. We should make the ability, like, give people the ability to be able to pull data from devices and push it somewhere, and so you don't have to worry about all that in between infrastructure and the end database and all these things that you don't know, you don't have expertise in, and so focus on the thing that you do really well and get the price down, and let other actors in the markets focus on the parts that they can specialize in. So OpenPipeKit gives, I hope, will become an important part of just Internet of Things market in general, being able to allow the market to be more flexible and allow more specialization.
Yeah, and I think another aspect of that, RJ, is that in a lot of what we're looking at for FarmOS, for example, is that we're pulling in multiple sensors, all of which might not come from a single vendor. And so being able to mix and match, as much as validating the same sensor for cost effectiveness, it's also about integrating across manufacturers and protocols. And that's something that a lot of the manufacturers aren't really spending a lot of time trying to support.
Yeah.
I guess we had a couple other standard questions that I thought we should also get out there too, which is also, what are some of the barriers that you're facing, and how could this group and collaboration help get over your barriers, technical, cultural, etc.?
There are no barriers. I think our biggest bottleneck right now is documentation, and that's documentation often by doing. And so there's only a handful of us who have ever used OpenPipeKit, and we've made some documentation around that. But with more users comes the potential, I hope, comes also more people sharing how they did something, and so that's my biggest, that's our biggest, that's my number one goal for OpenPipeKit, is to get more people using it and sharing, and I think that's key to innovation. And it's one thing to have a technology that is like the right thing at the right time, but if nobody's using it or telling each other about it, then it's not innovation. It's just an invention.
And what about adding more configurators? What are the barriers to expanding the list of sensors that you see? Is there a pretty good toolkit for building new ones?
Good question. So on the technical side, but that's also a social issue of finding the alignment of interests to get people to build pull and push drivers for OpenPipeKit. So that is one that we're still figuring out how best to really crack that nut. Most of us in this community are developers, and so one thing that we just need to be better at is reaching out to our own communities and saying, hey, you guys, like, this is a way of pulling data from things and pushing it to databases, and it's the way that we really like to do it, and you might like it too. I was excited when Public Laboratory got involved. They were looking at how we were our architecture, our technical architecture, and they were going. They were really stoked. they were really excited about how simple it was. That's where it was really the goal. So I didn't give a chance and a shout out to the Knight Foundation for funding a prototype grant for OpenPipeKit, and when we got that, I had all these ideas of what my idea of this perfect Internet of Things framework was going to be, and I think it was really that grant that gave me the time at my workplace to be able to step back and say, like, we're going to have to get a lot of people to build drivers for this, and we can't make assumptions about who those people are, what languages they have preferences for, what their technical background is going to be. We can't expect somebody to learn something complicated when they could just do it much simpler, their own unique way. And so the architecture that we settled on follows this thing called the Unix philosophy, which is to build programs that do one thing and do them well, and use text streams for communication. And so each of these pipe CLIs are command line interfaces. They can be written in any language. And all they have to do is print something to the screen to be able to accomplish what they do. And so that's just like a really, really straightforward way of structuring these things, and something that a lot of programmers can relate to. If you're a programmer watching, it's building a CLI, a command line interface, is just like a function. You just pass in variables and via CLI options, and then you return some output to the screen. And so that's we're really excited about the potential there. There's a lot of other, like the Google Brillo project, is people are trying to solve the protocol issue and say, like, hey, everybody, all thing makers and all databases, you just need to use the same protocol. And we're saying that might not really be possible, but if we build this glue, otherwise known as the pipes, otherwise known as the pull and push drivers, otherwise known as the command line interfaces, then they can be this interface to be able to build pipes between any device and any database, and use any language that we want. If this wasn't clear, the pull driver is the thing that just prints something to the screen, which is then received over a Unix pipe to the push driver, which pushes it to a database. And the two can be written in completely separate languages, and every single pull and push driver are compatible with each other because they communicate between text stream over the Unix pipe. So sorry if I lost anybody who was technical. Wasn't technical there, but the idea there is like, this is exciting because programmers already know how to do this. And this is just a really a good simplification of how to accomplish something we're all trying to figure out how to do.
Yeah, and it's building upon a lot of the already sort of existing concepts, like you said, the Unix pipe. Yeah.
Yeah. So yeah, we didn't really invent anything. This is just a suggestion. This is a way of doing things, and it's sort of just a realization that we had, that like, why are we doing it this other way? That was fun, but not really. That was more complicated than this way. So.
Yeah.
And we couldn't share code with each other. That was not fun.
Well, I think one of our other questions we typically ask folks is, how do you see this as being useful to supporting regenerative agriculture, or even agriculture in general? I know for me, the link seems clear, that being able to get kind of real-time monitoring in a simple way helps you kind of decision support, makes your production and operation easier in a lot of different ways. But I'd love to hear your thoughts on that question.
Yeah. So the thing that actually brought me to FarmHack, and the thing that drives me on this project, is that I am concerned about the state of agriculture, and the fact that it's not regenerative, and the fact that we're going to have more and more people and using more and more resources, and not really paying attention to food security and sustainability and these issues. So to me, this technology is potentially crucial, not guaranteed, for distributing food production. And I think that's a theory, but and Dorn, maybe you have some more science to back this up. But my perception of the world is that if we can distribute production and have it be a diverse set of production, that we're probably going to be better off. And so being able to take these off-the-shelf solutions and technology and apply them to our distributed food production processes, I think has potential. I'm not absolutely sure of that yet, but the idea would be that real-time data monitoring, how is that useful? We had the thing that turned me on to this was a farmer at a FarmHack event who was describing to me how they had greenhouses all over the place. They have scheduled people who are supposed to show up and check on the greenhouses. Someone didn't show up that day. It was a particularly hot spring day and all their starters died. That's just unacceptable. Like, that doesn't have to happen. It's difficult for farmers to be everywhere, and real-time data feeds really means that you get to be everywhere, at least to a certain extent, that the sensor can sense. So if there had been a sensor in that greenhouse, the farmer would have seen, no matter where he was, would have seen, like, it's getting way too hot in there. So I think that's just like for small farmers who are not necessarily who are already stressed out and overextended, to be able to give them something that gives them a peace of mind and also scale themselves and allows them to be in the right place at the right time. Like, maybe they didn't have to go to the greenhouse. Maybe they're checking it every day. I don't necessarily think they should be dependent on the technology, but having the ability to be able to say like, if you need to, like, this is there for you. You're gonna be able to know that everything's going okay. It's also going to alert you when things are not going okay. So so it's like it's not that this technology really necessarily like promotes regenerative agriculture, but I think it gives tools to people who can who can practice that kind of agriculture.
Yeah, that's a great answer. I think that anecdote about the farmer who lost all his starts in one day just because of not being there at the right place, the right time is a great example. And that is in a lot of ways one of the things that limits the ability of small farmers with a more kind of regenerative or sustainable focus, that limits their productive capacity. Having to be checking things all the time, or just labor is such a limiting thing. So anything that can kind of help relieve stress and possibly relieve some inane kind of labor that you'd have to be doing every day, every few hours, a lot of that can go a long way, I think. I'd be particularly excited too about, there's a lot to be said for farmers and drawing on their own experience and stuff, and habits to be making, especially early season decisions on things like planting times and stuff like that. But I think it would be an awesome use case of something like the Open Pipe Kit to be able to be integrated with something like a soil temperature sensor that would also kind of output some information on growing degree days for you or something like that. So you kind of can make those decisions on like, okay, is it the right time to plant now, or should I be waiting? That kind of stuff. Anything that supports those types of difficult decision processes is good in my mind.
I've also heard from some farm consultants that like one of their big things is when they're doing a consultation with a farm and deciding on those important decisions is like what happened, what is happening. Being able to, for the consultant to be able to pull that up quickly, I think is an important part of the support system that the extension agency provides, that hired consultants can provide, that this information technology allows us to be not just the farmer, to be in more than one place, but also other people that we want to be. Which is the case right now. Sometimes there's people that we don't want to be there. And that's one of the issues that we hope to solve. So giving you the choice of who sees your data.
Yeah, and I guess I would add that there's an aspect of one of it is sort of democratizing the economies of scale and reducing the economies of scale that's required to get some of the sophistication that's being used in precision ag, and bringing it down to be able to manage greater complexity in a smaller operation. And I think that's an important. There's a social aspect as well as the technical aspect, because I think a lot of scale that we see is often to accommodate the cost of capital improvements and to support that kind of the complexity that's required for that kind of precision ag. And I think we're seeing that some of those costs can be brought down dramatically with some of these approaches.
Yeah, I'm excited to from the research that I have seen around environmental monitoring in farms. I don't really see it happening in that, as you, Doran, you said, that democratized way. Democratized meaning that everyone can access it and reproduce these things. That's the question, is like, how do we get to that point where like this becomes that, like being able to like pipe data is like pulling out hammers and nails. You just know what to do with it. Right. And it doesn't need to, like, I don't want the Internet of Things to be this shiny iPhone experience.
Right.
Because it doesn't need to be this expensive limited access kind of thing. It just should be part of our everyday life, like the internet has become part of our everyday life. So it's possible. It's just a question of how do we get there. And in the case of Open Pipe Kit, again, that comes back to like getting people trying this, talking about it, telling your neighbors, and that's going to be the key to our success. I can't all of us programmers can't. We can't solve the world's problems. We can't make this more useful. It's the people who use what we make that are going to do that.
Cool. Well, with that, unless there are any other questions, I think that's a great place to leave it. Dorn or Mike, you guys have any more questions, or RJ, any more comments? Or?
No, that was great. Thanks, RJ.
Yeah, thanks so much, RJ. We're really excited to see more integrations happen in the coming weeks and months.
Thank you guys for coordinating this. It's great to be able to talk about it. It's really great. And if you're watching online, thank you for watching. Go to openpipekit.org. Come chat with us.
Great.
Say hi.
Absolutely.
Thanks, RJ.
All right, you guys.
All right, thanks, guys.
Have a good one.
See y'all.
See ya.